Hi everyone. In today's lesson, we are going to be focusing on another factor of physical geography and how external forces shape the Earth's surface. So I just kind of want to start with the root word that we see here, which is external. Generally, when we think of something as being external, we think of it being outside, on the outer edge of something. So that's kind of what we're going to think here as we talk about our external forces. So really, external forces are anything that is going to shape the Earth's surface or make it look how it looks, but on the outside of the Earth. Later this week, we're going to talk a little bit about internal forces and what's actually underneath the Earth's surface that shapes it. Today, we're talking about what happens outside the Earth's surface or to the Earth's surface to go ahead and shape it. So we're going to be talking about two main things. Those are weathering and erosion. Just to get some definitions going real quickly, weathering means the breaking apart of something, and it is a gradual process. It is going to take a little bit of time. None of this stuff is very fast. All of it's going to take years and years, sometimes hundreds of years, sometimes thousands of years to see what we see today on the Earth's surface. So weathering is breaking apart of something, and then erosion is the second step of the process, which is moving away all those smaller pieces that have been broken apart. Generally, when we're talking about the breaking apart and weathering, we are talking about rocks. So to move on to our first kind of example, weathering again is either mechanical or chemical. So there's two different types of weathering. So we already see we've got a little bit of a hierarchy here. We have got two types of external forces, weathering and erosion. And in weathering, we have two types. We have mechanical and chemical. And again, weathering is all about breaking down rocks into smaller rocks. So again, all about the process of breaking down something. In mechanical weathering, we see forces simply breaking down bigger rocks into smaller rocks. So you can see in this picture right here, you see what used to be kind of this full landscape of rocks. It's edged now. It has kind of sharp edges and corners in some places. Those have been broken down by things like wind, by things like snow, by water, by rain, any of those types of things that can break down rocks. We also see chemical weathering, which is our second type of weathering, and that is going to have to do with chemical reactions, which is why it's called chemical weathering. You have to have water and acid together to create chemical weathering. It is going to weaken rocks until they break apart. So again, in weathering, both types have to do with breaking big rocks into smaller little chunks or smaller rocks. All of it has to do with breaking it apart. Mechanical is kind of more natural. Chemical is going to have that chemical reaction component. So let's look at that a little bit more closely. Chemical weathering is going to be water combining with carbon dioxide to form something called carbonic acid. If you like soda, then you know what carbonic acid is, even if you didn't know, because that's what makes your drinks fizzy. So again, when water combines with carbon dioxide, it's able to eat away rocks. So when we think of chemical weathering, we can always kind of think of the C words, right? We have carbon dioxide, we have carbonic acid. That is chemical weathering. And you can see the most common type of rock formation that chemical weathering will form is a cave. This whole background is a picture of a cave, and chemical reactions are always going to create caves. Another type of chemical weathering is when it can produce a sinkhole. So if you're ever driving on the freeway or anything like that, and you see a giant part of the road that has just disappeared and it's a major hole now, chemical weathering forms that as well. So again, in chemical weathering, you're having water and carbon dioxide form. They make a chemical reaction that creates carbonic acid. When the carbonic acid gets onto the rocks, it's going to eat them away, dissolve them slowly over time until you get hole formations, which form caves, sinkholes, things like that. Generally, if you have a really strong rock, it won't eat it away as well. When we see caves, we're usually thinking about limestone and easier, kind of more soluble types of rocks. Going on to our second type of weathering is mechanical weathering. We are going to see that this is much more of like a natural process, no kind of chemical reactions, no acid or anything like that involved. Generally, we think of things like water, we think of things like trees and plants that have to do with mechanical weathering. In this example, you see that this is called frost wedging. Essentially, when you have a rock, there are always tiny little pores inside it, tiny little cracks inside it, so stuff can get in. Even if you don't see that in a rock, it's always there. So if water gets into a rock, and then let's say overnight it gets really cold, water freezes. When water freezes, it expands, that can crack the rock or break it apart into smaller rocks. So then we can get some funky rock formations. If you skateboard and you have ever been skateboarding over the sidewalk and it's been even, and then you trip or you fall, that is because plants can also do mechanical weathering. So plants can grow up through the sidewalk, through rocks, and break it apart as well. So that is a different form of mechanical weathering too. So again, mechanical weathering is going to be all about water or plant life kind of getting in between rocks and breaking it apart, whereas the chemical weathering was much more about acid and chemical reactions that create caves. Mechanical weathering is not going to create caves. So erosion is our second type of external forces. Remember, if weathering is breaking it all down, erosion is taking all that broken down material and moving it away. So erosion happens after weathering. It always goes weathering and then erosion second. And those little bits that get broken down, things like gravel, soil, sand, rock, they're moved by three types of forces: water, wind, and ice. You can always think of World War I as a mnemonic device to remember that if you need to. So again, water, wind, or ice are the three types of erosion. Those are the three forces that can move the weathered down material away. So how does water contribute to erosion? Water, as you can see in the pictures, it wears away the earth just gradually over time, right? So if you have heavy rain in a certain area, it can kind of just smooth down all that material that's already been broken away, make it smoother. It can also work with large bodies of water like rivers, oceans, things like that, that can kind of break apart chunks of land. That's how you get formations like this in the bottom left picture called river deltas. That's basically when you originally, all of this was land, but over time, weathering occurred, made all this material loose and small, and then the rivers just kind of push through it over time because they have strong force behind them. So again, water erosion is generally going to make things smooth. You're generally going to see water in the picture if water erosion has happened. How does wind contribute to erosion? Wind is generally just going to pick up all of those little materials that have been broken down. So anytime you see a sandstorm or a dust kind of dirt storm, that's always going to be wind erosion. So anything that's not held down by plants or buildings or anything like that can be stripped up by the wind and pushed around somewhere else. And wind also kind of has that aspect of creating smooth surfaces, right? If you see sand dunes, generally that's going to be wind out in the desert that has moved those around. If you see sandstorms, same thing. Usually wind. When we think about it, wind is going to be the weakest kind of type of erosion. So it usually isn't going to be able to pick up huge rocks or anything like that. It's going to deal more with dirt, more with sand, stuff like that. And finally, our last type of erosion, the strongest type of erosion, is ice erosion. Ice is going to have to do with glaciers. So we're not talking about little ice cubes here, little pieces of snow or anything like that. We are talking about glaciers, which are essentially giant, massive kind of bunches of ice. And as they move, they pick up everything underneath them. So all these glaciers just become huge masses of snowy, hard ice, rocks, dirt, all that kind of stuff. And they are going to carry away all the rock and all the soil underneath them as they go on top of them. Think about if you've ever dropped a piece of ice on the ground, it picks up everything, right? It picks up little pieces of fur, little pieces of hair, little pieces of dirt or sand. Glaciers are going to do the same thing. As they move, so as they melt a little bit, we know ice will move as it melts a little bit. It is going to scrape against the land to carry all that stuff away. And the really important thing to remember is that it is going to create U-shaped valleys. So if you see in this background right here, we can see a U-shaped valley. It's going to gradually create those types of things. An example of this is the Great Lakes, actually. So all of these used to be filled with ice. Over time, that ice has melted. The glaciers have moved. But when they moved, they carved out all of this land and all of these formations so that we still have those lakes there today. Those wouldn't have been able to be moved by anything else because ice erosion is always going to be the strongest type of erosion. One more thing that I want to go ahead and show you guys. So a V-shaped valley is always going to be water erosion. Water is not as strong, it's kind of the middle ground. It is going to be water erosion, whereas ice erosion, remember, is going to create those massive U-shaped valleys. So what I want you guys to do now, you can pause this throughout and you can work on your assignment, or you can work on your assignment now that I've gone over some of this stuff, refer to it, and finish that assignment called external forces.